Hello everyone, and welcome back to another video. Okay, so I try to look for some circular linkless LeetCode problems. This was the only one that I could find. Again, I might have missed it, who knows, but I think one video of LeetCode problem for a circular linkless should be enough, and now I'll just move on from the linkless in general. Because I think I'm on the topic for pretty long now. Should probably start moving on quickly. Anyway, so LeetCode problem 141, linked list cycle. So given the head of this linked list, determine if the linked list has a cycle in it or not. There is a cycle in a linked list if there are some nodes in that list that can reach again by continuously following the next pointer. And then blah blah blah. Internally, pause, however you say it. I'll just say pose, is used to denote the index of the node that tail's next pointer is connected to. Note that pose is not passed as a parameter. Return true if there's a cycle in the linked list, otherwise return false. We have example 1, 2, and 3. Very simple. So a linked list, let me just explain that. A linked list with a cycle is conceptually like a circular linked list because you can go around and around. But in a textbook term, a circular linked list is usually a deliberate design where the entire list is one clean cycle, meaning the tails points to head. So in this LeetCode problem, the cycle might start in the middle, not necessarily at the head. So we usually just say this is a linked list with a cycle, not a circular linked list as data structure. But it still counts as a circular linked list. Or just think of it as like circular linked list is a special controlled version of a list with a cycle, Just think of it like that. Okay, so I'm going to write out the code, and then afterward, I'll explain it line by line. So, and again, this question is just asking, is there a cycle or not? So it's a Boolean. All you're returning is true or false. So we have head, if head is equal to null, or head.next is equal to null, return false. This one just shows that, hey, is there even a list to begin with, or is the list too short? So if list too short, to have a cycle. This is like the base case, basically. Now, I'm going to write out list node, and we're going to call it a slow. We're going to have head, list node fast, and we're going to also give it the head. And then we're going to write out a while statement. While false is not equal to null, and fast.next is also not equal to null. Then slow equals slow.next. Fast equals fast.next.next. If slow equals fast, return true. And then finally return false. And that's it. Very quick, very simple. And then I'll just pretty much explain it. So we have the if. This is the base case again. If head is null, that means the list is empty, meaning there's no cycle. And if head.next is also null, then that means there's only one node. Like example 3. And that single node can't loop unless it points to itself. But in standard LeetCode inputs, they won't give that for this problem. And even if they did, you could treat it as a special case. So for lists of length where it's like 0 or 1, like example 3, then we just immediately return false. And same thing, showing it, they wanted false basically. So, and now we initialize a slow and a fast pointer, and I'll explain it why. So in this while loop, or basically the main loop, we keep looping as long as fast is not equal to null and fast.next is also not equal to null. Why do we have to check both? Because inside we do fast equals fast.next right here. we need to make sure we're not doing .next on a null like reference. Otherwise, it's going to be null pointer exception. So if fast or fast.next becomes null up here, then that means there is no cycle and the loop ends. And now we have to move the pointers basically. Think of the pointers as, so for the slow, it means the slow is going to move one step. And fast means it's going to move 2 steps. Slow moves 1 node forward, while fast jumps like 2 nodes. If there is a cycle, then you have to kind of imagine like them running on a circular track, right? If fast is moving twice as fast, at some point the fast will like lap slow, and they will be on the same node at some point. And that is exactly why we have the if statement. We are checking if they meet. If slow is equal to fast, that means they're meeting to the exact same node in the memory. If they ever meet, there's only one possible. That's only possible if fast got to loop around and catches up slow, meaning there is a cycle. So as soon as this happens, we can basically say that the cycle exists, and we can return it true. Now, if the loop does end, that means we exit the while loop, meaning, and that only happens if fast is equal to null or fast.next is also equal to null. That means fast has hit the end of the list, which means there is no cycle, and we return it false. And that's it. Let's look at example, for example, right? Example 1, we have, let's say fast and slow are both pointing at 3. And then like we look at the while statement, slow will move 1 step at a time, fast will move 2 steps at a time. And then again, fast isn't fast or fast.next is not equal to null, meaning we can continue the while statement. Now slow becomes 0, fast moves this to -4, and there's another pointer, and it moves to 2 because it's moving 2 steps at a time. Again, fast isn't hitting node, or fast.next is also not equal to null. And then what happened is we move again, slow equals next, and then fast moves 2 steps, and they eventually both hit slow equals fast, and then we return true. Yeah, I think that's it. There's nothing else really to explain. I'll explain the time and the time complexity and space complexity at least. So time complexity will be big O of n. Now, it's big O of n because in the worst case scenario, and I'll probably write it down just because it might be better if I write it down. In worst case scenario, the fast pointer goes through at most n nodes before either hitting null, which means there's no cycle, or entering the cycle, and then at most n more steps to meet slow. Basically, if say there is never a cycle to begin with, it's gonna just the fast is just gonna keep moving forward at n times, meaning that's the worst scenario. And if there is a cycle, it's gonna enter the cycle, and again, it's gonna take at most like n more steps to meet slow again. So that's why it's big O of n. Now space complexity is much simpler. It's just big O of 1, because we're only using the slow pointer and the fast pointer, nothing else. So there's no like extra data structure that grow with input size like array, list, or set. So extra memory is constant, which is big O of 1. And that is it. So with the next video, I'll probably do a different topic besides linked list. And yeah, thanks for watching. I forgot to press run and submit, so I'm just gonna quickly do that. Test result, case 1, case 2, case 3, easy, submit. Perfect. And there it is. That's it. Thanks.